an interview?
Sure. Just gonna show my family on vacation.
It's okay. No. Such a nice thing to see.
In Hawaii.
Are we good?
Yep.
All right, we're good. Welcome, everyone. This is the first R-bootcamp session. R-bootcamp came about because a number of us in the department who were using R in various different preparations had recognized that a lot of people were interested in R, but had hesitance in using it because it is a programming language and that does introduce some additional complications when you're trying to conduct your statistical analysis. So today's R-bootcamp is being conducted by Kelsey Panville. Kelsey is a
second year.
Thank you. Second year graduate student in our behavioral neuroscience program. And she's been using R since you got here, right?
In undergrad too, yeah.
Yeah, so she's been using R forever. And today she's going to give us an introduction to R, or as Kelsey likes to call it, R for noobs.
Yeah, that was you, but yeah.
So if you guys want to give her a nice round of applause, let's welcome.
Okay, so we're gonna go through some stuff for about an hour, and then there'll be a 30-minute session after. If you have any more specific questions, maybe you have a line of code that's not working, you want me to look at it, that kind of thing. We're gonna primarily focus on the code, so I'm not here to like teach you all about stats concepts. That's for your classes, hopefully. And then with each R bootcamp, we'll have a data set, an R markdown sheet, and a reference list, those kinds of things, which are all on Lisa's website. And then we have a couple others. So next month will be about general linear modeling. We'll have some multivariate the month after that, and then generalized as well. So what I'm going to go over today is very basic stuff, how to even start R, how to start a new script, how to import your data, those kinds of things. So if you know all of that already, you can leave. I don't want you to have to sit here for a full hour and be bored by me. But if you don't know, then I will show you. So Lisa is just an overachiever and made a website for herself. So you can go to this website.
Doesn't have very much on it right now.
That is the URL. And on here, that's how you'll get the data set that I'm going to walk through. That's how you'll get this R markdown that you can take home with you and use if you need it in the future. So you would just click on this R bootcamp link, then go to the first session here. And then this is where you can download the files. So the R markdown file is what we're going to kind of go through step by step. The data file, all the code that I'm going to show you today is with that data file. So if you want to do it at the same time as me, that would probably be beneficial. Is everyone following the website? Do you need me to like say it out loud or anything? No? Okay. Okay, so Lisa spelled normally. And then VANGSNESS.
Okay, so her last name.
Yeah. Did you get that?
Yeah, I can't read what it's
.wix and then site with an SITE.com. Hopefully that works.
Okay, so it's not just me. I'm not getting it.
I'm not getting it. Oh, the link to the email they sent out. You can just click on that. I'll take it.
There you go. Thank you.
Okay.
I did see Lisa's hometown.
And if you, I mean, you don't have to follow along with the data set. The markdown sheet also goes with this data set, so you can always walk through it another time as well. Okay, so the very first thing that you need to do is to download R. You have to have R to use RStudio. What you see up here is RStudio. I like using RStudio. It's a bit more user-friendly than R is, but I think Lisa still uses R instead, so whichever you prefer, really. But you have to have R to use RStudio. So once you have all of that, you would open up and see this. So I have a script open that we can walk through. So how do I even get this thing up here? That's your script. That's where you could save your code. So if you want to maybe share your analysis with someone, you could write it all down up there and email that to them. So that could be very helpful. And then down here is your console. So what you run down below in the console does not save to your script. So you need to be making a conscious effort while you're coding to save things in your script. So how to open a script, is that what you're gonna ask me?
Can I ask, what sort of file does it save as? Like when you save the script, is it like a special R file?
Yeah. Mm-hmm.
Can it only be opened in R? Can you open it
I believe you can open it in other things like Xcode if you have that. I think our files will also open in Python.
You can also open them as text files.
Yeah, you could just read them.
But you lose your formatting when you open up an R file and a text file.
Okay, so let's say I want to start off and write a script. I would go to File, New File, to our script, and now I have a brand new blank document basically to save all of your code that you're going to run in. Is everyone following that? Okay, so I would want to save this in some location so I can keep up to date with everything and not accidentally lose it. So you would save that wherever, really. And then that's also where you're going to want to start your path. Okay, so I saved my file, and now I'm going to add everything to my path. So what that is basically just where is the computer going to look for your data file and for your R script. So I'm going to go to Session, I'm going to go down to Start Working Directory, and I have some options here. So I could save it to my source file location, so that would be where I saved this script. So I just saved this on my computer to a folder called R project, so I could do that. Or I could go ahead and choose my directory, and then you can navigate through all of the files on your computer that you have. So does everyone see how that works? So again, it's really important to set your script, to set your path where your script is and where your data is. If not, then it cannot open your data. Cool. Okay, so now that I have a script, I'm probably going to use some packages. So I'm going to install packages. You can do it one of two ways. You can type out the code and install your package, or you can go through the drop-down menu. So let's say I want to install a package for generalized linear modeling. I would type install.
Why would I want to use a package? What is a package?
So R is a free programming language, and it's a big thing. There are a lot of different things that you can add into your R to have new functions, basically. But it really would not be possible to just have everything in R when you download it. It would be too big. So instead, you have the freedom to add on these packages. So if I want to run a generalized linear model, I need a package to do that. If I want to make a really fancy graph, I need a package to do that. So that's what a package is. It just has extra code that you download to your computer. You only have to do this once unless you're changing computers. So on this computer, the one that I'm working on, I've downloaded this before, so I won't need to do it again if I'm using it on this computer. But if I were to pick up Nathan's computer and Nathan hasn't downloaded it, then I do need to install that package again. Does that make sense? Thank you, Haley. Okay, so let's say I want to do the multi-level package, the generalized linear modeling package. I would type the package name. If you're ever wondering what the package name is, you can usually just Google what capability you're looking for. So like graphing in R, what's the package name? You can Google that, and then you'll get a bunch of responses, and you can kind of sort through and see what package you like the best. So I'm going to type in the package name, and then I'm going to type something else kind of fancy, and that is dependencies equal true. So what that means is that if I'm trying to do something in this LME4 package and it's using another package, it's just going to take care of it for me now and install that package. So if this rests on something else, oh, I installed. This is a great point. R doesn't catch your mistakes in your typing, so it'll just give you an error. So here's your first example of what an error looks like. I forgot the C. So I just did something that's a really nice shortcut. You can, if you type something wrong or just want to rerun something you recently ran, you can hit the up button in your console, and that will recall the last thing that you typed. So I just went up, and that recalls the line where I have my mistake. Now I can type in C, and now it should run.
Chelsea, can you turn off the
And would it also be possible for you to move the window up
Oh,
a
yeah.
little bit? Because those of us in the back can't see the lines at the bottom.
Like you want me to zoom in?
Zoom in and then move up the very bottom portion of the window. So like make it smaller so that it's above Nick's head.
It's above Nick's head. Oh,
Sorry, Nick.
really, Nick?
Yes, thank you.
Like, is that better?
Yeah,
Can you
that is
see
a little
above
bit
Nick?
better. I think
Okay.
there are just some of us you just can't see.
Do we want both lights off? Is that better? Okay. We'll go with it. Okay, so
This package isn't available for my R version.
You can always
you need to update your R.
by going to the
Your R or your R Studio?
There's my R.
So yeah, mine's going crazy.
Yeah, mine, like.
Yeah, you get a bunch of crazy text when you install packages. So that should be normal. Okay, so I installed this package. There's a reason that I wrote it down in my console because I don't need to do that every time. I don't want to save that in my script. What I do want to save in my script though is when I open that package. So if I want to use that package that I just downloaded, I need to load it into what's called your library. And that just means that it's available for you to use once you load it in. If you don't load it in, you can't open it. So that is something that you would want to put in your script and you would want to do each time you start your script, or each time you restart your R session, really. So I would want to go ahead and write that in my script. Once I'm here, I can run or execute this line of code in a couple different ways. Commonly used is just putting your cursor on that line and hitting run. The way that I like to do it is having my cursor on that line and hitting Command Enter. That's also going to execute it. It's just kind of easier than having to like use your trackpad if you're on a laptop and like going up to run every single time. So Control Enter or run, whichever you prefer, really. But again, I want to make sure that's staying in my script because I'm going to need that every time I restart my R. Does that make sense to everybody? Cool. Okay, so I've got a package now. Let's get some data. So I'm going to import my data file. So my data file right now is in a, I touched my computer.
Should we download the data file from that website?
If you want to follow along with me, yeah, that would probably be better than you having to do it on a new data file that you have. So I'm going to call my data file a variable. My variable is going to be called MYD. You could do whatever. Maybe you want to call it data. That's fine. But my data file will be saved into that variable name. So in this case, MYD. And then I'm going to read in that data file. Yes, Lisa?
What's the funky arrow doing, Kelsey?
So I prefer the funky arrow, but I did use the equal sign throughout the markdown as well, just so you know that it does the same thing. So the arrow is essentially an equal sign, but there are cases where the equal sign will not work, which is why I've just adopted the arrow pretty much whenever I'm assigning things to variables. So we'll use that a bunch. Basically what it means is that everything to the right of that arrow, I am now saving in to what's to the left. So I'm going to read in my CSV file, and I called it choice drug data.csv, and it's going to save to that variable. If I had named it something else, it'd be saved to that other name. There are some cases, though, that maybe you have missing data. This data file that I provided doesn't have any missing data, but let's just say that it does. How I would get around that or make sure that the computer acknowledged.
So how do I know that if I'm like reading in my file, if I just type the name, how do I know it's going to find it in my computer?
Your data script, your data file should be where your path is set. So because I have that data file in that folder that I started my script in, it can read it. If you don't have it set up that way, it cannot find it. Does that make sense?
So I have to move the data file.
So we can go back through setting paths again really quickly now that I think everyone has a data file probably. So it's downloaded somewhere. Let's say it's like on your desktop in a folder. You would go to session, set working directory, choose the directory, and then wherever that is. So you can see in my computer, on my computer specifically, that choice drug data is in this folder that I have my path in, and so that's how I can open it. Let's say I had it on my desktop, it's not going to find it. that answer your question? So that's important. Setting path is like the first thing you should do once you have a new script, or else you can't execute your code. Okay, so going back, let's say I have some, yes, Cassie.
So in the window where I can see search results and like help thing, I have files selected and it's showing my directory pathway. Is that normal? You can double check.
Yeah, you can do it that way too.
So you can tell where it's.
Yeah, you can see a bunch of stuff in all these tabs, whichever one is most helpful for you.
I moved it.
So yeah, you can see that my data file is there, so it's gonna work. Yeah. Okay, so let's say, I'm gonna keep going a little bit more. So let's say I have some missing cells in my file. I wanna go ahead and make sure that R is reading those correctly. So I'm gonna have R put a period in all of my missing cells. And that's what that na.strings is doing there. So it's just gonna put a period. If you wanted it to be something else, you could do like just a space even. But again, that's what it's doing. It's just helping the computer read the missing cells correctly. So that's just a fun tidbit. Now, let's say I wanted to share my script and I'm sharing it with someone who doesn't really know how to use R. You should use comments. That's really important. So I'm going to write my first comment, and a comment in R is denoted with this pound or hashtag, whatever you want to call it. So I'm going to say that I am importing my data file here. Whatever is helpful for you to remember what each line was doing. It's very important just in case you maybe come back to the script in a month or two and you don't remember what na.strings was doing or what read.csv was doing. Those are very helpful, especially when you're sharing. Yes?
Why do I have to stick a little hashtag in?
So if I don't have this hashtag, it's going to think that it's code. And now it's going to try to run importing my data file here, and R doesn't understand what that means. So adding in the hashtag means that it's going to skip over it. It's not going to try to execute anything in there. Okay, so now I have a data file, but I can't see it yet. So let's take a look. The easiest way to look at your data is just to run a simple summary. So you would type in summary and then type in whatever you called your data. So in this case, I called it MYD, so I would type summary, then command enter. And now that's going to appear in the console. So hopefully you can all see that. So in this data file, it looks like I have about 6 columns, and it's going to automatically treat things that have numbers as continuous information. So it's going to give me a mean, a max, median, all those kinds of things. And we'll go over how to change those later. So that's what it looks like when you have your data file summarized. Is everyone good with that? Yeah. Oh, that was for generalized linear modeling. I was just showing how to load a library. It's not important for anything that you're going to do today. That would be something that you learn in another R bootcamp. Okay, so another way that I could look at my data, if I want to just make sure that it loaded in correctly, I could double or just click this over here, and now it's going to open a nice new window and show my data. So I could scroll up and down. But I have a lot of rows of data in this data file, so that's probably not going to help me that much. Another way that you could pull that up is typing in that line that it did there. So view MYD, and the same thing will happen again. So these are just different options if you maybe were wondering if it read in your column names correctly or something like that. That's how you could open your data file quickly in R to make sure that it looks good. Okay, so now let's say that it did read my column names wrong. Maybe I don't want it to say subject. I want to change it. So there's this very fun function. It's the concatenate function, and I use it a lot. It's very helpful. So I'm going to change the column names to whatever I want. So names is what's going to modify those column tops. That's just a built-in R function that you have. And then I'm going to use this fun concatenate function. It's just a C and then an open paren. And now I can change all my names in order. So let's say I want subject instead to be ID. Maybe I like that better. Then let's say I want, maybe I still like group. I'll leave group. Session, maybe I want to be day now instead. maybe I want LL delay to just be delay. So you see how I'm just changing the names, and it should be in order of how they were originally. So if I'm trying to change just choice, I still need to have something to fill for all of those others. You can't just skip to the last one, or at least I don't know how to skip to the last one. So if you did.
You put a number, so after.
You can pick your column number after where she has names and ID. So if you were to want to change, for example, the third column, you would just do this bracket 3, and then put your,
Then I could change the
yeah,
third
so if you
column.
wanted day, then yeah, you could
Okay.
erase everything and just name their third column day. So
Got
the
it.
number according to whatever number column you're looking at.
You should write that down if you wanted that, because that's not in your R markdown.
No, I'm not even able to look that. No, it's okay.
Okay, so I came up with a bunch of new names, and now I'm gonna change that. And then to check that I really did change them, I'm just gonna rerun the summary. You can see that my names are now different. So before it was subject instead of ID, and now I've changed it to ID. So if that's something that you're needing to do when you upload your data set, that's very helpful. Okay, now let's get into modifying the actual variables. So let's say that I want to scale my data, or maybe make a mean center of something. You can do that too. So the very first thing that you can do is just check what kind of variable you're working with. And I like to do that by typing in one of two things. If I know exactly which one I'm looking for, I can do it with class. So the first thing I would do is type in print, then I'm going to type in class, and then whatever variable I want to check. So let's say I want to check what is LL delay. It says it's an integer. So what is an integer? It's a whole number. If I had decimal places in the LL delay column, it would come up as a number instead. Yeah, Lisa?
What does the dollar sign mean after my?
So the dollar sign after MyD means that I'm accessing specifically LL delay. If I just type in MYD, it's gonna do it for all of your columns, basically all your variables. And I'm wanting to specifically access LL delay. So I do that by writing the overall data frame or data set name, which is MYD, and then a money sign and whatever the column or variable name that I'm looking for. So in this case, LL delay. Okay, so it's an integer. I could check all of my variables at one time if I want, and use the string. So now it's going to do it for all of my variables. So it looks like ID is an integer, group, day, LL delay, Charles and phase, and choice are all integers. So it's just reading it as whole numbers. But I do have one that it read automatically into as a numerical number, and that's dose. That's because I have some doses that are like 0.25. So it's automatically picking up on that it's not a whole number. So why is that important? Well, if it classified your variable as characters, so as a string instead of numbers, you can't do math to it, basically. So you can't divide A by 6. It wouldn't let you do that. So if you need to convert at all, that would be how you figure out if you needed to. So that could be important if you have a weird error that's just telling you that you can't do something. That's usually one of the first things that I check if I'm trying to troubleshoot my errors. So let's say that I do want to manipulate LL delay somehow. Very commonly in my lab, we scale LL delay. We basically just try to put it on a similar scale to what our dB is. So how I'm going to do that is, again, accessing just LL delay by using the money sign. Now I have one of two options. If I'm going to change the numbers, I can change them in their place, which means that the original way is gone. I've saved new values over those. Or I can save a new variable completely, so I have my old and my new. So the first way I'm going to do it is to save a new variable, so I'm going to give it a new name. So let's say it's LL delay scaled now. And then this is going to save it in a completely new space in my data set. It's not going to write over my old variable LL delay. Does everyone follow that? You'll see that once I run it basically. So let's say I want to subtract 5 from LL delay for all of my values. I'll do that. I have too many parentheses. And I'll go ahead and run that. And now I can summarize my data again and see what it did. So before, this will be easy because I went the new way first. So these are the original values going from 5 to 60 that I subtracted and saved that to a new variable. You can see my new variable is here. It's still in my data set, but it has a different name. I didn't change my original values. So now everything's subtracted 5, so I'm just going from 0 to 55. Does everyone see how I did that? But I could, let's say I knew for sure that I wanted to scale a certain way, I could modify my original. So how I would do that would be very similar to this line, but instead I would delete the scales. So now the way it's written there, where my cursor is, it's going to access the original column. And so now those numbers are going to change. So when I run that, and then when I summarize my data, now you can see that my original values are different now. So they were 5 to 60, but now they're 0 to 55. Does everyone see how I changed the originals? So sometimes you might change the originals, sometimes you might not, but it is helpful to know both ways just in case you decide that you want to go back. However, if you did want to go back and you modified your originals, it's really simple. You could just reopen your original file. You haven't written over the actual data set here. So I could just go back up here and run this. Now you can see that it's all back. So it's basically just like starting over. You have not modified your original data set at all in the code that I have up there. Does everyone see that? So it's not like the end of the world if you accidentally wrote over your original values. You could just reopen your file, which can be helpful if you mess up. Okay, so another really common thing is to do mean centering. And there are also many ways to do that. So let's say that I want to mean center dose or dosage, for example. I want to access just that variable again. So I'm going to use my money sign again. And I could do this many ways, really.
Can you give us a quick definition of what mean centering is and maybe one sentence about why someone might want to do it?
Okay, so mean centering. So up there right now, you can see that the mean of dose is 4.38. So maybe I want to have my intercept of the model be at a specific location, let's say not mean, or let's say mean. So you can move that around with mean centering. Does that help, Lisa? Do you want to go ahead and say something else?
Did that make sense to everyone? Like, does anyone have any questions about what mean centering is? I know that there's a lot of terminology that comes up within the context of this workshop, and we're sort of moving through things very quickly. And not everyone has gone through the stat sequence. So I want to insert a couple of opportunities for people to ask questions if they have them.
I just have no idea what's going on.
For some reason, my summary and my print functions won't work no matter what I do. That is just like that.
I think your definition is probably okay.
Okay.
I didn't find anything wrong with it. I just wanted to make sure that there was something in there about maybe what it was.
Yeah. Okay, so very easiest way, at least in my opinion, is just to subtract the mean. So the summary will give you the mean. So like I just read it is 4.38. So I can go ahead and mean center by subtracting the mean from all the values. So if I run this and then summarize my data, you'll see that everything is now going to be shifted. So the mean for dosage now, it looks like is about 0. But that's kind of annoying that it's negative 0.0001. That's going to bother me at least. Maybe not you, but it's going to bother me. So there's another way that I can make sure that it's legitimately going to be 0. And I can use the scale function. So I'm going to do the same thing pretty much. And I'm going to type in dosage. Going back to that whole missing values thing, let's say I did have missing values. If I wanted to go ahead and mean center and get around those missing values, I can type in na.rm equals true. And that's going to calculate the mean. Oh, I got an email, sorry. That's going to calculate the mean disregarding your missing values. If you don't have that in there, it can produce an error, which is kind of annoying. Oh, what did I do wrong? Okay. So I forgot to write center equal true to tell it what to do. I gotta throw that in there. Okay, guess not.
I don't know the scale function.
I don't think it needs this. I think that's for my next example. Yeah, okay, there we go. Run another summary. See how it changed there. So this time I created a new variable so you could compare. So before it was negative 0.0001. Now it's going to be actually 0, which is just nice to look at. Okay, last possible way is using the mean function, which is just another built-in R function. So it would be similar to this, but instead of scale, I'm going to put in mean here. And now that's when I can work around my missing values with this. I think it's spelled true. Okay, and that's going to do, again, the exact same thing, except I've, of course, done it so many times, it's making very weird values now, so ignore that. But lots of options for mean centering, many different ways. Let's do some transformations now. So let's say you have a theoretical reason to log transform day or log transform LL delay, let's say. You can do that very similar to how we were mean centering. So whichever variable you're interested in doing it to, let's say it's going to be LL delay. I'm going to access that variable. This is actually going to save over the way I have it written. And then I'll just type in the variable again. Okay, so what that did to my LL delay, if you can see it over there, is it log transformed my entire column. And it wrote over my original. So if I had wanted to save it into a new variable name, again, I could just change this to something new. Now when I run this, I have a brand new column that did the log transform of those values. So does everyone see how you can do that? Other common ones are like square root. So you could do a square root transform of trials in phase, let's say. Okay, so I just square root transformed trials in phase now. So those values are now all square root transformed. Maybe you need that. I don't use it very often, but just in case.
Back real quick to your last centering example. You just set that variable to
The mean one.
And you didn't actually center it. You just set everything to the mean.
Yeah, so because I mean centered based on something that was already mean centered, the math got really messed up.
It doesn't normally, because you're just setting it to mean of that.
So do I need to type in?
At least in mine, whenever
Oh,
I was doing
okay,
it,
yeah,
it just
yeah,
set everything to the mean.
No, you're right, you're right. It should be this. Good catch, Haley. That will subtract the mean from everything. I was using the mean function. My bad. Does that make sense? Yeah. So yeah, does everyone see what Haley just pointed out? So before, all I did was accidentally change all the values to the mean of dosage. The way to actually mean center is to subtract the mean from all your values. So I just had to add in this part that I have highlighted. But again, like many options, and I did write it down correctly in the markdown, so you should download that and keep that. Yeah, okay. Let's make something categorical and continuous now. So in this data set, I have two groups, and that is a categorical variable. So I want to make that a categorical variable. Right now it's not. So the first thing I'm going to do is make it a factor. like this. If I am wondering whether or not I did it correctly, I can basically just ask R to double check for me. And I can do that by typing is dot factor for whatever I just did, which was group. And then if it is a factor, it'll tell you true. If it's not, it will say false, and you need to fix whatever typo you probably made. So right now it's factored, and I'll show you what that does to the summary as well. So before I had the min, max, median for a group, and now it's treating my two groups as a categorical variable. So I have, it looks like 5,179 observations in my group 1 and even more in group 2. So in my lab, at least, we love to do sum to zero coding or effect coding. Right now, it's just going to default to dummy coding, but I'll show you how to make it contrast or effect coding. So how I would first check that I am even dummy coding, we can use that print function again. We're going to print out the attributes of group. Okay, so what it's showing you is that it's categorical and it has 2 levels, just 1 and 2 right now. So I want to change that, and I want it to be 1 and -1. And the way that you do that is to use the contrast function. So we'll type in contrast and then whatever you're contrasting. So in this case, it will be group again. And then you do need to tell it how many levels to contrast to. So in my case, there are 2 levels. So what I'll do is specify 2. Let's say I had 3, I would just change that 2 to a 3. If you had 4, that 2 now becomes a 4. So I'll run that. Oh, I typed something wrong. Okay, and then we'll see how that changed, this command. So now you can see that instead of it being 1, 2 in terms of my levels, it's got contrast or effect coding of 1, -1. And that's going to change your interpretation of your model output, which is something that we'll get to in later sessions when we're actually modeling. But it is important to know how you have categorical variables coded. So in my case, when I am looking at my output now, I'm looking at the mean of my groups. I'm no longer looking at just group 1. But again, that's something that we'll cover more. This is just showing you how to do it if you were wanting to change it. Is everyone following with that?
So originally it was labeled as 1, 2, so now it's labeled as 1s, -1s.
Yes.
Contrast sum does affect coding.
Yeah.
What if you wanted to
There
change?
are like a million names for that.
What if you
Some
wanted to do
zero.
dummy coding? What would the
I think it'll default to dummy coding, right, Lisa?
okay. The ones that do?
Yeah, so it,
As long as it's labeled as a factor.
yeah. So that's why I didn't include it. It just is going to be that automatically. But if you were wanting to do this, you have to run those lines to change it to contrast or effects or sum to zero coding. Okay. What else should we do? Oh, another important thing to note is just how to get your data out. So if you log transformed or square root transformed a variable and you want to save all those new values out into a new data file, you need to do that. So it's pretty easy. You're just going to use the write.csv function, and it's going to write this new data file that you've modified into a new file. So I'll write.csv, then I write whatever I'm wanting to save, which would be my dataset, MYD, and then I can give it a name. So let's say that I just want to call it myd.csv. Then I would run that, and now what it did is write a brand new CSV file to wherever I just saved it, which was in this folder where I had my path. So it is now called this. And now I have all of these weird values that I made when I was playing with stuff. So if you wanted to save all of that, that's how you would write your new CSV, which can be very helpful if you are log or transforming somehow and you want to save your new variable, your new values. Does everyone see how that works? And it will save this file to where you have your path set. So if I have my path set to a different folder, that's where I would need to go look for it. And it will also pop up here, which is what Cassie was looking at earlier. Or I guess it didn't, I would have to refresh it, but it will pop up there now. So you can see that my new data file is in there. That's another way to check to see where it went. So speaking of which, another fun tip with R is this little help tab. I use this pretty often if I am looking for a package and I don't know what it's called, or I want to do some new analysis and I just don't really know where to start. So for example, well, I already typed in this, we'll just go with that. If I was interested in nonlinear modeling or nonlinear analyses, I could type that in and R is going to give me a bunch of different options for where to look. So maybe I want to do nonlinear modeling within the BRMS package. I can read this and it will give me a bunch of information about it. So very helpful to know. Maybe I didn't want to use that and I wanted more specific help, like with the NLME package. Now I can read about that. So definitely use your help tab if you're searching for something and you just can't find it. Another option is to type those kinds of things into your console. So let's say I messed up with the mean function and I just want help with how to use it. I can type help in here and now it's going to basically show me what to do. So in that case where I was using it earlier, it's going to show you how to use it, different arguments that you can input. So like how I use that thing to skip over missing values. And then it'll even give you more things to go read. So very helpful. Does everyone see how that works? I could have also just searched it up here. It's really whatever you want to do. Oh, another thing that's very helpful in R are these vignette little descriptions of a package, basically. So let's say I'm interested in Bayesian modeling, we'll say, and I want someone to help me with that. It will give me all of the different things that I could possibly need help on. So I could look in more specifically to doing multivariate analyses in that package using that help command as well. So if you're stuck on something and you don't know what to do, most of the time you can just use the help or the little search bar in R and it will tell you. Another thing that I'll say is that you should probably just like Stack Overflow it. I use that a ton. You just kind of enter your error message into Google with Stack Overflow. Guaranteed someone already came across it and they can just give you the code that will help you pass whatever your little hurdle is. So it's definitely a learning process. You need to go and look on Stack Overflow and they probably have the answer. Another thing that I like that maybe some of you don't know about is demos. So one really cool one that you can run is the graphics demo, and it will show you a bunch of different graphs. So it just, there we go. It will show you how to plot all these things. So within my console, it made this crazy graph. How did it do it? It will show you how it did it in all this code. So yeah, this is helpful. Like if you're just looking for how to graph something and you like have it in your head, you just don't know how to get it down, you can basically just kind of scroll through this graphics demo and it could help you. I've done it before. So yeah, the code is in there. I'm not like scrolling through all of it because there's so many options. So like in this past one, if you wanted to change your label to time, it will show you how to do that very quickly in this little demo. So I've definitely stole some code from this demo, write it down. It's very helpful if you wanted to scale stuff. There are other demos. Another one that I've used is the nonlinear demo. And again, it will give you code for how to start nonlinear modeling, how to graph it if you want. So these are helpful starting places if you're just confused, looking for more help. Yeah.
While you're going through those demos, you suddenly quit out of them somehow in some way. Tell us how you do that.
Oh, so I was scrolling through them. I'll type it in again so you can see what I was doing. So let's say I wanted to go back through the graphics demo. So it's saying at the bottom, you can see how to scroll through is just to keep hitting enter. And that's also how you get out of them. So if I want to.
Wanted to stop halfway through. Like I saw one.
Oh, yeah.
That was the graph.
If you want to start, you type N, I think, oh, no. What was it? I don't know. How do you get out, Lisa? Do you know?
I think if you just hit escape, you fill the code for stuff.
Oh, okay, there you go.
So that's
You
helpful,
escape.
like if you're running a model and it's just churning and you don't want to wait for it and you need to go do something else. Or if you realize that there's some error in your code that is going to make your computer run it for basically ever. You can just hit the escape key and it'll break the loop. Then you can move on and do whatever it is you need. There's
usually the same thing if you're kind of stuck waiting for a model to run, there's usually like a stop sign that will appear here. So let's say you were executing a model that's going to take like 30 minutes and you see that you had a typo. You can hit stop and it will stop where it is. It won't make you sit for 30 minutes and then fix your typo and then keep going. So that can be helpful. Let's say I wanted to take this plot and do something with it. You can export it to all these different options. So if I wanted to just put it in a Word document, you could copy it out this way. You can also save it as an image or a PDF. Maybe you made a really ugly graph and you just don't want to see it anymore. You can also just hit the broom so you don't have to look at your horrible work. Same with the console. I've occasionally gotten like millions of lines of red text that was just killing me to look at, and I can go ahead and clear that with the broom as well. Might seem ridiculous to know, but I have done it before. And I think that was pretty much all I wanted to walk through today. So if anyone has other questions, we can go through those. You should definitely download the markdown sheet from Lisa's website and keep that in case you wanted to go back and look through how to mean center and all the different options or ways, or even do effect coding if you don't do that all the time. So make sure you download that and keep that. Any questions?
I think that this is a good time for general questions.
Yeah.
If you have specific questions about your code or you want to work on this with some file that you have and try to load in your own data, that's something that we can go through afterwards. If you have like general questions for Kelsey about what she wants.
So these were just like the very basics on how to import your data. Future boot camps will do a bunch more. So how to actually model with your data. These are just like the simple things that they don't really go over in class and tell you how to do. So this way you have the code and can do that before you get to that point where you don't even know how to put your data file into R. It's helpful. Okay, well, if no one else has questions, we can just go on to any more individual questions. Lisa and I can help you. If not, you are free to go.
Thank you.
Did you learn anything? Good.
I'll see you later.
Oh.
Yeah.